represent the phenomena like creation of continents and oceans, the development of mountains, mechanism of earthquakes and volcanism can be explained only with plate tectonic theory. B. Isaacs, J. Oliver, L. R. Sykes, W. J. Morgan, Exley Pichon and other scientists are attached to this theory. The outer layer of the earth are divided into the lithosphere and asthenosphere. The division is based on the difference in mechanical properties and the method for transfer of heat. The lithosphere is cooler and more rigid, while the asthenosphere is hotter and flow more easily. In terms of heat transfer, the lithosphere loses heat by conduction, whereas the asthenosphere also transfers heat by convection and has nearly adiabatic temperature gradient. Earth's lithosphere, the rigid outer shell of the planet, including the crust and upper mantle, is fractured into 7 or 8 major plates and many minor plates or platelets. The lithosphere included the crust and top mantle with its thickness range varying between 5 to 100 km in oceanic part and about 200 km in the continental areas. A plate may be referred to as the continental plate or oceanic plate depending on which of the occupy a larger portion of the plate. The plate motions range from 10 to 40 mm per year at mid-Atlantic ridge to about 160 mm per year for Nazca plate. The fact that the movement of plate is now a well accepted fact. The mobile rock beneath the rigid plate is believed to be moving circularly. The heated material rises to the surface, spreads and begins to cool and then sinks back into deeper depth. The cycle is repeated over and over to generate what scientists call a convection shell or convective flow. The slow movement of the hot, softened mantle that lies below the rigid plates is driving force behind the plate movement. Where the plates meet, their relative motion determines the type of plate boundary. There are 3 types of plate boundary. First type is divergent plane boundary. Those are also called constructive boundaries. Those are where 2 plates slide apart from each other. At the oceanic plate splits, the ridge forms at the spreading center, the ocean basin expands and finally the plate area increases, causing many small volcanoes and shallow earthquakes. The second type is convergent boundaries. It occurs when 2 plates slide towards each other. Subduction zones are of 2 types: ocean to continent subduction zone and ocean to ocean subduction zone. In the case of ocean to continent subduction zone, the dense oceanic lithosphere plunges beneath the less dense continent plate. In the case of ocean to ocean subduction, older, cooler, denser oceanic crust slip beneath less dense oceanic crust. At zones of the ocean to ocean subduction, a deep trench forms in an arc shape. The upper mantle of the subducted plate then heats and magma rises to form a curving chain of volcanic islands. At the continental collision zones, there are 2 meshes of continental lithosphere converging. Since they are of equal density, neither is subducted. The plate edges are compressed, folded and uplifted, forming mountain ranges. The third type of boundary is transform boundaries, occur where 2 plates are neither created nor destroyed. Instead of 2 plate slides, or perhaps more accurately grind past each other along transform faults.